Modern software development requires moving away from treating a repository as a passive storage locker. To ship reliable code, you have to turn that codebase into an active, automated orchestration engine. Over the next 6 minutes, we are going to build a complete continuous integration and continuous delivery pipeline from scratch. We will construct the workflow, configure the execution environments, and secure the data. To follow along, you only need 3 things: an active GitHub account, a basic repository with some code, and a foundational understanding of YAML syntax. Mastering GitHub Actions takes a static folder of text files and wires it up to become a fully automated, self-executing software delivery pipeline capable of handling massive enterprise-grade deployments. Let's build it together. Look at this diagram. Every automation process begins with a discrete event, like a developer pushing code to the main branch. That event acts as a trigger that awakens the workflow. The workflow serves as the top-level container for all the automation logic. Inside that workflow, you define jobs. Notice how these job tracks sit side by side. By default, jobs process in parallel, executing distinct tracks simultaneously. Zooming in on a single job, we find the steps and actions. These are sequential, individual tasks, like running a test script. All of these hierarchical elements are represented as actual files inside your repository's workflows directory. Because this architecture is strictly nested, when a build fails, you don't have to guess. You can instantly isolate the exact step inside the exact job that threw the error. To write your first workflow, open your repository and click the Actions tab. GitHub scans your code and suggests starter templates based on your primary language. For this example, locate the Java with Maven card and click Configure. The graphical hierarchy we mapped out translates directly into the generated YAML blocks. You can clearly see the name, the on trigger, and the jobs keys. Before modifying this code, look at these vertical alignment guides. The most common reason a workflow breaks for a beginner is a simple indentation error, breaking the parent-child relationship. By generating this file from a template, you bypass the syntax boilerplate entirely, allowing you to focus immediately on your application's custom build logic. Scroll down to the Runs On key inside your job. This single line defines your runner, the actual server machine that executes your code. This chart compares your 2 options. On the left, GitHub-hosted runners provide a fresh, clean virtual machine for every single job run, requiring 0 infrastructure maintenance. On the right are self-hosted runners. If your project requires custom hardware like GPUs or needs direct access to a private internal network, you route the job onto your own hardware. Selecting the correct runner dictates exactly how much environmental control you maintain, balanced directly against the time you are willing to spend managing those servers. Workflows often require dynamic data at runtime. Instead of hard-coding values directly into the YAML, we inject them using contexts. Look at this property dereference syntax. By wrapping the variable github.actor in double curly braces, the runner pulls the exact username of the person who triggered the run. There is a strict security requirement here. If you accidentally print the full GitHub context to your public logs, or if you hard-code API keys into this file, you expose your infrastructure to immediate risk. The proper mitigation is to store those keys in repository secrets. When you reference them strictly via the secrets context, the string emerges in the terminal window automatically masked as asterisks. Understanding the difference between general environment contexts and secure repository secrets is what separates a functional script from a secure pipeline. As you scale, duplicating complex build files across dozens of repositories creates massive, unmanageable technical debt. You solve this by changing the workflow's trigger event. By setting it to on workflow call, you convert a standard workflow into a centralized, reusable workflow template. When calling this template from another repository, do not reference a mutable branch name. Instead, link to it via its exact commit SHA to ensure the version is cryptographically locked. Pinning that SHA ensures that if someone modifies the upstream template, those changes cannot unexpectedly execute and compromise your downstream production pipelines. Now commit your changes to the default branch. That commit triggers your first live automated workflow run. Watch the blocks lock into place. Monitor the Actions tab. You will see sequential green checkmarks appear as each job completes successfully. And if you expand the logs, you will see your repository secrets perfectly masked. By combining runners, injecting dynamic contexts, and structuring your logic with reusable templates, you have built a scalable automation engine. Your next step is to explore the GitHub Marketplace and start dropping pre-built community actions directly into your new pipeline.